All right, in this last video in section 13.6, we're going to look at problem number 4 that says solve each equation. And we see that each one of these equations involves logarithms. And we're going to make use of these new properties we've been studying in this section to help us solve these. But before we do, I first want to highlight the fact that logarithms are not defined if their input is less than or equal to 0. Okay, so in other words, the thing you're taking the log of, if it's less than or equal to 0, then the resulting logarithm will not be defined. So let's illustrate that with an example here. Like let's say I have the log of -4. Okay, so if this thing is to be defined, and here, since I didn't write in that base 10, this really is just a log base 10. It's implied. This would be the exponent such that 10 raised to that exponent would equal -4. See, the problem here is that 10 to any number, whether it's positive, negative, or 0, can never come out to be a negative value. Okay, so this right here is just not defined. And if you use your calculator and you punch in log of -4, it says undefined. What if I do log of 0? Undefined, right? Anything that's 0 or negative, okay, its logarithm will be undefined. So why is this such a big deal? Well, it's a big deal for lots of reasons, but in particular, the reason why I'm highlighting it right now is that when we go to solve equations like this, it can turn out to be the case that we could get a solution such that if I plug it back into the original equation, I could wind up getting the log of a negative, or say the log of 0. And if that's the case, then I'm going to have to toss out that solution. It's really the same kind of thing we saw when solving rational equations. There, it could be the case that we got a solution from just our algebraic steps, but then it was one of these restricted solutions, meaning that if we plugged it back into the original equation, we wind up getting a division by 0, so we had to toss it out. Okay, same kind of issue here. All right, so now let's go ahead and solve these. So looking at part A, I have log base 2 of x squared plus log base 2 of x, and that's equal to 6. And notice I have a sum of logarithms here on the left. So as my first step, I'll go ahead and just combine those two logarithms. So put them together. So the log base 2 of x squared times x. And here I'm just using that product to sum property. Now x squared times x is x cubed. So I have that. And now what I could do is I could take this logarithmic equation and I could convert it to an exponential equation. I can do 2 raised to the 6th power, and then that has to come out to equal x cubed. So I'm going to get what? X cubed is equal to 2 to the 6th. And 2 to the 6th is 64. So now I'm asking, what number can you cube to get 64? Or put another way, if I take the cube root of both sides, in which case I just get x on the left, what's the cube root of 64? Well, that's 4. Okay, so here's the solution I get from just doing the algebra. And now, as our little check here, am I going to run into any problems? Well, if I plug in 4, I'm going to get log base 2 of 4 squared plus log base 2 of 4. And then this apparently is equal to 6. Now, I could go ahead and simplify this whole left-hand side and yes, verify that it does equal 6. And that'd be a nice exercise in just using the properties of logarithms. I'm not going to do that right now. What I really care about when it comes to the check is, look, when I plug 4 in, am I going to get something inside a logarithm that is either negative or 0? In the case here is no. I'm not going to run into any problems because I'm taking here the log of 4, and this is just the log of 4 squared. So since these inputs are both positive to the logarithms, this right here is a keeper. All right, let's try B. Got log of x squared minus x minus log of x minus 1. Okay, so now I have a difference of logarithms, so I'll go ahead and put those together using the quotient to difference property. So that gives me the log of x squared minus x for the, and then sorry, all divided by x minus 1. Okay, now we have a log base 10 on the left, so 10 squared is going to equal this expression we're taking the log of. So in other words, x squared minus x over x minus 1 is equal to 10 squared. Okay. Notice on the left-hand side, I can simplify that by factoring. So I'll go ahead and do that. Factor out that x. On the right, 10 squared is 100. And notice here, the x minus 1's divide out. And oh, that just leaves me with an x on the left. And so I get this result that x is 100. Okay, am I going to run into any problems here if I plug in 100? Well, let's check it out. So I would get the log of, this would be 100 squared minus 100 inside that first logarithm, minus the log of 100 minus 1, and this all apparently comes down to equal just 2. Well, again, I could go ahead and check this by simplifying the left-hand side and verifying that this left-hand side does come out to equal 2, but I'm not going to. What I really care about is this expression here less than or equal to 0, and is this less than or equal to 0? And the answer there is no, they're not. These are both positive quantities, so again, we are good. X equals 100 is the solution. Okay, and the last up is C, log base 4 of x cubed minus log base 4 of x. Again, a difference of logs, so I'll go ahead and to start get the log base 4 of, and this would be the quotient of x cubed over x, and this is just 0 still on the right. Right, now notice x cubed over x, that's just x squared. And now let's go ahead and exponentiate. So 4 to the 0 is going to equal x squared. So we have that x squared is 4 to the 0. So in other words, x squared is equal to 1. And so now let's go ahead and take square roots. And I'm going to get a plus or minus when I do so. And so that's going to give us x is equal to plus or minus 1. All right, cool. So then let's go ahead and just check. Are we going to run into any issues? Well, if I plug in x equals negative 1, what am I going to get? I'm going to get log base 4 of negative 1 cubed minus log base 4 of negative 1 is equal to 0. That's what I'd be checking. But wait a minute. Right here and right here, these are both negative. So in fact, neither one of those expressions are defined. So since these things are not defined, that says that x equals -1 is in fact not a solution. Okay, so I have to toss out the -1. Is +1 okay? Well, for that, yeah, we're going to come out all right with x equals 1 because now we're looking at log base 4 of 1 cubed minus log base 4 of 1. And we're asking, is that 0? And again, I'm not going to run into problems here because 1 cubed is certainly positive, 1 is positive. So there we are okay. So our final answer would be that x is 1. We toss out x equals -1. All right, that's going to do it. Thanks so much.